Hello, in this video we'll be studying about empirical formulae and molecular formulae. In order to understand how to figure out these formulae, we need to know what is the meaning of the word empirical formula. Empirical formula is simply a simplified version of a molecular formula. So when you look at the molecular formula, it looks like C2H6. We can simplify this formula further. So C2H6, that means carbon and hydrogen are in the ratio 2:6. I can simplify it by dividing it by 2. If I divide both numbers by 2, I get 1:3. So my empirical formula would be CH3. Similarly, I can simplify the other formulae by dividing it by a number, and I would be able to get the answer. So if I divide it by 2, I get the formula CH3. If I divide it by 5, in this case I divide it by 5, I get CH2. In this case, if I divide 3, 6 and 2, if I each divide, could I divide it by 3? I could divide these two by 3, but I cannot divide this one by anything, so I cannot simplify it further. C6H12O6, if I divide all of those by 6, I would then get CH2O. So that's how you derive empirical formulae if the molecular formula is given. Molecular formula gives you the actual number of atoms of each element in a molecule. That's what we had looked at in the previous slide. In order to calculate some of the molecular formulae, we would first need to find out the empirical formula. So let's find the empirical formula, and then we will go and find how to calculate the molecular formula once the empirical formula has been done. So as seen in my previous videos about mole calculations, I always believe in keeping the calculations very simple using a structure, and this is a structure you could follow for finding the empirical formula. So what you need to do is any elements that you see in the compound, you need to write it down in that manner. So you write N and H in that manner because nitrogen and hydrogen are there in that compound. Write down the given data. The data could be given to you in a percentage or it could be given as a gram. Whatever is the data, just write it down underneath the elements. So you got 82.4% of nitrogen and 17.6% of hydrogen. Once you've written that, you would now need to write down the atomic mass. Atomic mass of nitrogen is 14, hydrogen is 1. So the first step you've got to do now in your calculation is to find the moles. And the way we've written it out is literally you just need to divide the first number with the second. So 82.4 divided by 14, that would give you about 5.89. Hydrogen, straightforward, 17.6. So you get 2 moles. You get 2 mole values. And in order to find out the answer for the next step, you've got to divide both of them by the smaller number. So 5.89 is the smaller number. So I would need to divide both set of moles by this smaller number. So when I divide it, I would get 3 here. So the ratio is 1:3. That means 1 nitrogen and 3 hydrogen. Therefore, your formula is NH3. Let's try another question. So you could pause the video now and use the same concept as before. And if you had paused the video and solved the question based on the calculations I'd shown you, so welcome back and let's check the answers. So we've got carbon, hydrogen as elements. We write down the data. Data is now given in grams, so that is fine. We've got the data here. Atomic mass 12, hydrogen is 1. When you divide 1.24 divided by 12, I get 0.103. This is 0.26. Divide both values with the smaller number of moles. So I divide both sides with the smaller number of moles and I get, this is 1, this is 2.52. Now, you cannot round it up or round it down from 2.252. So if you get numbers like this, you've got to think, by what number should I multiply this number to get a whole number? So you start with 2. If I multiply by 2, would I get a whole number? In this case, yes, you would get approximately 5. So that is your answer. So you would say the answer is, now if you multiply this side by 2, you've got to multiply this side by 2 as well. So you get 2 here. So your answer now becomes C2H5. On the same way, if you had if your fraction came as, or the mole simplest ratio came as 1 and 1.33, then you would try the same thing. You would multiply it by 2. So when you multiply it by 2, you would get 6. So you get 2.66 and 2. Now that's not a whole number, so we won't multiply it by 2. Then you would try multiplying it by the next higher number, 3. So you get 3.99 and 3. Now 3.99, we can say it's similar to 4. So your mole ratio would be 3:4. So if that was the data here, you would say your answer was C3H4. So anytime you get the answer for the simplest ratio, if the answer is not very close to a whole number, you would do the same thing. You would multiply the numbers by 2, then move on to 3 till you get a number close enough to the whole number. Don't just round up and round down, but just be very precise in your calculations. So let's find out now the molecular formula when the empirical formula is given. So at the start of the video, we looked at molecular formula and we saw that it was quite easy to simplify molecular formula. We just divided it by a number to simplify the ratio. But what about you've been given the empirical formula, or in the calculations that we've been doing, you've found the empirical formula and you've been asked to find the molecular formula. Again, as I've said, keep it simple, follow a structure for your calculation, and you'll never get a wrong answer. So to find molecular formula from empirical formula, just use the 2 steps. You have to find the value of n. The value of n is found by dividing the molecular formula mass, which is usually given. So molecular formula mass is always given in the question. So I'm just going to write molecular mass here, 78.12, divided by empirical formula mass. And what this means is you have to find this. And how will you find this out? You will use your empirical formula, which would be given to you, or you would have just found out, and then you would find the mass of all the elements in that formula. So carbon is 12, and atomic mass of hydrogen is 1, so that is 13. So 78.12 divided by 13, that is 6.009. So approximately you can say the value of n is 6. So that is your first step done. In the second step, you multiply the empirical formula. Now the empirical formula in this question is CH. And if it's given in the question, you use it, or you would have found the answer and you get that. So that is CH multiplied by the value n. The value of n you've just said is 6. So when you write it like that, what you're doing is any numbers that are at the bottom here, you're multiplying it by 6. So C1 multiplied by 6 is C6. CH1 multiplied by 6 is 6. So let's say if your empirical formula was C2H3, and then you had to multiply it by 3. If n was equal to 3, and if this was the empirical formula, then C2 times 3 and H is 3 times 3. So C2 times 3 is 6, H 3 times 3 is 9. So the answer is C6H9. So that's how you find out the empirical formula or find out the molecular formula from the empirical formula. So what we've looked in here is we've seen a variety of ways in which you can find out the empirical formula and molecular formula. We've looked into this structure that you would use this kind of a calculation strip to find out empirical formula. Molecular formula, if you have to find from empirical formula, you first find the value of N, which is the molecular mass divided by the empirical formula mass, and then you find the formula, which is empirical formula multiplied by N. If you're given so this is molecular formula from empirical formula. If you have to find empirical formula from molecular formula, then you just have to simplify. You literally have to divide the molecular formula numbers by a number that would simplify the formula. So this is a summary of what we've looked into this video. It was all about empirical formula and molecular formulas. So I hope this video has been useful. So thank you for listening and watching, and I'll see you at my next video. Thank you. Bye.